So this question is divide an array into subarrays with minimum cost first. So the question is given to you. You are given an array of integer nums of length n. The cost of an array is the value of its first element. For example, the cost of 1, 2, 3, this array, is 1, while the cost of 3, 4, 1 is 3. Right? The reason is simple. As in the question is given that the cost of an array is the value of its first element, right? So we need to divide. Okay? You need to divide nums into three disjoint contiguous subarrays, and we have to return the minimum possible sum of cost of this subarrays. Okay. So see, here is an example. See, the array is 1, 2, 3, 12. Okay. So we can divide the array like this. This is the first our array. Let's suppose this is second, and this is third. Now, the first array, the cost of first array will be 1, the cost of second array will be 2, and the cost of this third array will be 3, right? So total cost will be 1 plus 2 plus 3, which is 6, right? Similarly, you can see the other examples too. Okay. Now, what will be my approach to solving this question? For solving this question, see, what we have to do, we have to divide this array into three disjoint contiguous subarrays. Okay, contiguous subarrays, and there should be three subarrays. Okay, now we want to also minimize. Okay, we want to also minimize the possible sum of the cost of this subarrays. Okay, so we have to divide the array like this, that each array, okay, in each array, the first element should be minimum, as minimum as possible. Okay, now see, anyhow we divide this array, we have to take the first index, of course, because if we are dividing this array into three parts, the first array, okay, the first part will consist of the first index, right? So we have to consider this first element. Even also this element has the maximum value. Even also the maximum, this the first index of the array having value equals to like int max. Okay. Then also we have to consider this first element. But for considering other two arrays, okay, or I mean for considering other two first element of the array, we have choice. We have choice. We can choose the minimum one. Okay. So what I am going to solve, what I am going to do in this question is, I will find other two minimum element. Okay, rather than the first one for dividing the subarray. Okay, for finding the minimum sum of the cost of the subarray. Okay. So for this, simple. See, if we see here, n is equals to 50, right? So very like small constraint. So even if you can solve this question in big of n square, or I think even you can solve this in n cube also. Okay. So the brute force approach of the solving this question will be uh, in big of n cube, big of n cube. Okay. Okay. But I am going to solve this question in big of n or n log n. Okay, I can do it in n log n. Okay, how I can do this in n log n? Simply by sorting this array and finding other two minimum element. Okay, okay. So let's find the two minimum number. Okay, excluding the first element of the array. Okay, so I will write here int m1 is equals to, okay, let's me see first of all that all the elements should be positive only, okay, and not only positive, it should be greater than 0. Okay, so I can initialize with this 0 and not 0, sorry, I have to find maximum, no, I have to find minimum. Okay, so I wish I should initialize this with int max, or we can see the maximum value is what, 50, so I can write this as 51. Okay, no problem. And again in m2 should be equals to what, 52, right? Not 52, 51, let's suppose. Okay, now for int I equals to 0, not 0, I equals to 1. Why I equals to 1? Because I don't want to compare my this two numbers with the first index, because for the first element we haven't any choice, we have to consider it in the division of subarray, right? So I is less than what? Nums of size. And now we have to perform operations for finding minimum element. Okay. Now, first of all, I will write if this m1 is what? If this m1 is less than, or I will write greater than, okay, this nums of I, then what we have to do here simply, we have to write m1 is equals to what? Nums of I, right? Yes or no? And here I will write m2, if m2 is what? If m2 is uh, greater than nums of I, okay. Hmm, let me first. Okay, we have to find the distinct index also, right? So for finding distinct index also, we have to avoid those that index on. Okay, so for this I will also write that int m1 idx, right? So I will write int idx1. Okay, why I'm writing this, you will know. -1. Okay, and first of all, let remove this first of all, and here I will write this idx1 is equals to what? I, and num1 is equals to nums of I. Okay, and I will add a second loop for m2. Okay, and here I will have to, let me copy this and use for this also. Okay, just we have to do this for m2, right? So m2, okay, m2, and also we have to write and what, and what, and this I should not be equals to what, this idx1. Why? Because this is the index of the m1, right? This I. Okay, so now I will write here this m2 is equals to what? Nums of I. Okay, so we got all the elements. Okay, so we have to find what we want to find. We have to find sum of the cost of the surveys. Okay, and now what will be all of the costs of the arrays? See, the cost of first array will be simply the first element. Okay, first element of the nums. Okay, and the second, okay, the cost of the second survey will be this m1, and the cost of third survey will be this m2. Okay, so for finding the sum, just we will return what we will return, nums of 0. Okay, and here see, it's written it should be greater than equals to 3, right? So it always in array there will be minimum of three numbers. Okay, so we don't have to worry about that. Okay, so m1 plus m2. Okay, so let's see if our solution is right. Okay, so it's right. See, so it was a very easy question, and also if we are willing to solve this question by on your, with your own, right, by not saying the solution. Okay, let me clarify you that even if we don't know this approach, okay, basically this is a logical approach. Okay, not I haven't used any data structure or any like famous algorithm to solve this question. This is a basic logic. Okay, but also if we are not getting this logic, okay, and not after this video, okay, before watching this video, if you are not able to solve this question with this logic, there isn't an issue, because you can also solve this by normal running three nested loops. Okay, for like each loops for each element. Okay, and for minimizing the sum. Okay, right, it can be possible, it can be possible that you can solve that this question by that logic, that logic of time complexity big of n cube. Okay, because the constraint is very small. Okay, because the highest value of n is 50, right? So 50 to the power 3 will be simply 125 into 10 to the power 3. It means 1.25 into 10 to the power 5. Okay, which is okay. Okay, so I hope you got this solution and got this approach. If you are having any other doubt, any other thing, any other suggestion for me, please feel free to comment. And if you like this video, then hit the thumbs up button. And if even if you don't like this video, then hit the thumbs down button, which is the dislike button. Okay. And yeah, if you haven't subscribed the channel yet, then please do consider subscribing this channel. And thank you. So this